Hey ladies and gentlemen, good afternoon or good morning. We're going to be going over the notes for Charles and Gay-Lussac's law. This is assignment number 12 in your notebook. It should be the next blank page after our Boyle's Law lab that we did last time. So let's get that started. To my sub, if at any point you need to, when I ask you to pause the video, up on the dot cam, push the enter button and that'll pause it for you. So let's see. Let me get this set up for everybody. So we have Charles and Gay-Lussac's law. Let's say gas laws. And I guess I better zoom that in so we can see that a little bit better. This is assignment number 12 in your textbooks. So, Part E, all right, Part E. Okay, Part E. Now, this is a continuation from the notes we had on 11, so we'll start at E, and we're going to do Charles's law, plural possessive there, Charles's law. Please, there we go. Okay, so Charles's law deals with volume and temperature. We saw this kind of come into play with the fire syringe lab we did. Now, number one, since temperature's involved, they're directly proportional. Directly proportional. So, for example, let's say if you've, let's say if we increase the temperature, let's say we get some hot water and we put a balloon into the hot water. What's going to happen? The volume of that balloon is going to increase. So directly proportional. You can use the balloon into hot water example. The air is going to warm up, the molecules are going to expand. And if you increase the temperature, the volume of that balloon is going to, and we'll do that in a demo next week in class, we'll do that a little bit. We'll see the balloon actually increase in volume as we put it into hot water. Hot H2O there. And then actually the opposite's going to occur as well. If we were to take that balloon and put it into icy cold water, make the temperature go down, that balloon would begin to, the molecules after a few minutes would get cold, they'd start to shrink up, and then the volume of that balloon would actually begin to get smaller if we put it in cold water. So any of the laws that are dealing with temperature, this one and then Gay-Lussac's law in a moment, they're going to be directly proportional to each other. Number 4, and this is a biggie. Temperature must be in kelvins when you use these equations. So temperatures must be in kelvins. One of the two biggest mistakes doing calculations that students make is that they forget to change Celsius into kelvins. And that's going to be, if we give you in the problem degree Celsius, you need to add 273. We'll turn it into kelvins. They're not called degree kelvins, they're just called kelvins. So that's really big. In fact, recommend if you got a highlighter, you know, that's a big one. That's one of the biggest mistakes. Don't make that mistake. So our base equation for this is, it's set up as a fraction initially. It'll be temperature 1 divided by volume 1. The starting temperature and volumes are going to be equal to the new temperature, you know, if you heat it up, and the new volume. Now, this isn't the easiest way to get the problem set up. What I'd like you to do is we're going to cross-cancel these. And when we cross-cancel, I'm going to do it in pencil. Just watch for a second. Don't write this down. We're going to multiply both sides by V2. This will cancel, so please just watch here. And then over here, I want to get rid of V1 over here, so I'm going to multiply both sides of the equation by V1. V1 will cancel here. And then what we end up with, now let's write it down. We're going to get volume 2 times temperature 1. I know it's kind of backwards. The subscripts are mixed up. Will equal now temperature 2 times V1. Now this is much easier for us to rearrange the equations when we go to solve for either the new volume or the new temperature in the problem. So I'm going to go ahead and erase this stuff. Well, I'll just leave that there, but that's how we do. We just cross multiply it. And I think we give that to you on your practice page. So what I'd like you to do is to take a moment, and what I want you to do is we need to all solve, let's see, let's do volume 1 equals volume 2 equals, just like we did with Boyle's law. I'm going to have you whiteboard these out. And down here we'll do temperature 1 equals and temperature 2 equals. So you're going to have to rearrange these equations. And I think what I'll do is I'll have groups 1 through 2 on your whiteboards rearrange algebraically to solve for this one, and then 3 through 4, and then groups 5 through 7, and then groups 8 through 9. I'll have you rearrange those. So for the sub, if you would, please push the enter button for a moment so that they can get that done. All right, so let's see, students. Let's see if you got this worked out. Hopefully groups 1 and 2, hold up your boards. Hopefully you had, let me make sure I look at the right one, volume 2 times temperature 1 divided by temperature 2. Over here for groups 3 through 4, hold up your boards. Let's see what we got. And hopefully you've got temperature 2 times volume 1 divided by temperature 1. And groups 5 through 7, hold up your boards. Let everybody see here. Did you get volume 1 times temperature 2 divided by V2? And then lastly, groups 8 through 9. Hopefully you all ended up with I got to make sure these look like V's. V2, the new volume times the initial temperature divided by V1. So, sub, if you need to, push the enter button for a moment. And then you can push the enter button again to make it go. Now that we've got those filled in there, and this is going to be part of what your homework will be, and I'll show you how to set that up in a moment on your paper, we're going to get part F done here. And part F is going to be Gay-Lussac's law. And Gay-Lussac's law deals with pressure and temperature. And since temperature is involved, just like with Charles's law, really the only difference between Gay-Lussac's law and Charles's law is that we were substituting P for the V's. So they're directly proportional. That should be an O. Directly proportional. We're still on the screen. I haven't covered you up yet. And let's see. Oh, yeah, number 2. So in our fire syringe demo, I shoved that piston down, which made the made the pressure go way up, and it also made the temperature go way up. So that was a really good example there of Gay-Lussac's law. Increase the pressure, you increase the temperature so much it'll burn. And then number 3, the opposite is true. If we were to lower the pressure on a system, it's going to make the molecules be spread apart a little bit more, less collisions, and so the temperature is going to drop as well. So these are directly proportional to each other. So just like we did before, Gay-Lussac's law, the base equation is going to be pressure 1 over temperature 1 is equal to the new pressure divided by the new temperature. And then just like we did before, cross multiply these out, which means the T2, oh, that's my little reminder. So T2 is going to live next to P1, so let's do T2 times P1 is going to, and T1 will get cross multiplied, and it'll live over here next to pressure 2. So there's our base equations. And just like before, let's have you solve for pressure 1. That'll be groups 1 through 2. We'll do temperature 1, groups, let's see, what did I say? Oh, that'll be groups 5 through 7. Sorry, I didn't mean to jump out of order there. For volume for pressure, sorry, getting off there, getting pressure 2, that'll be groups 3 through 4, have you do that one. And then for temperature 2, that'll be groups 8 through 9. So Sub, I'll have you hit the enter button for a moment. We'll have the groups do that, and then when they're ready to present in a couple of minutes, Sub, please allow them, like, they need about a minute to do this, maybe 2 at most, okay? All right. All right, so now, when we go through this, we need to, hopefully we found out groups 1 and 2. Hold up your boards. Hopefully you have pressure 2 times T1 divided by the new temperature. And then for temperature, let's see, for groups 3 through 4, hold up your boards. And hopefully we got on there that you got pressure 1 times temperature 2 divided by temperature 1. Groups 5 through 7, hopefully you, hold up your boards. Hopefully you've got P1 times the temperature 2 divided by the new pressure. And lastly, groups 8 and 9, hopefully you worked out that pressure 2 times T1 divided by P1. And somebody in my period 1 class realized the equations are the same up here. You just get rid of the V and make it a P, and everything comes out the same. So with that, end of our notes. Oh wait, but I need you now. You're going to work on getting started with Charles's law right over here. And oh, and I accidentally started working on this one. This isn't our classes. So I'm going to end this video here. Open up your notebook to the back of Boyle's law, and I'll show you how to do that.